Dear students, today we are going to discuss very important and easiest problem from Fourier series. So easy. So before we are going to start the problem, you just give the like symbol and subscribe this video. Share it with your friends, isn't it? Okay, let us take an example. Obtain the Fourier series of f of x equal to x into sin x from 0 to 2 pi, isn't it? So this is the interval. So let us start the solution. F of x equal to x sin x and the interval is 0 to 2 pi. So the Fourier series is f of x equal to a naught by 2 plus summation n is equal to 1 to infinity a n cos n x plus summation n equal to 1 to infinity b n sin n x. So this is a required Fourier series. So this is a required equation, isn't it? Okay, now a naught equal to 1 by pi from 0 to 2 pi f of x dx. This is the formula. So f of x is x into sin x dx. So let us choose u equal to x, dv equal to sin x. Differentiate u, that is dx. Integrate dv v equal to minus cos x. So integration by parts. Let us use the formula. So integral u dv equal to uv minus integral v du. So that is the formula. So just replace the formula x into minus cos x and then minus into minus plus 0 to 2 pi cos x dx. Then I'm going to differentiate, integrate the second term only. So minus cos x as it is and then cos x will be sin x. So 0 to 2 pi. So this is the thing. Okay. Next one. A naught equal to 1 by pi. So substitute first upper limit minus lower limit. So 1 by pi minus 2 pi. What about cos 2 pi? Cos 2 pi is equal to 1. So the answer is A naught equal to minus 2. Isn't it? Okay, now let's start the second thing. A n equal to 1 by pi 0 to 2 pi f of x cos n x dx. So 1 by pi 0 to 2 pi f of x is replaced by x sin x cos n x dx. Okay, so there are three terms x sin x cos n x. Now I'm going to merge sin x and cos n x. There is an existing formula sin a cos b. Okay, so let us use that formula. I can expand, then I can take x. Okay, so now consider only sin x cos n x. Okay, then so this is the formula to find the answer. Yeah, this is an equal to 1 by pi 0 to 2 pi x into sin a plus b minus sin a minus b by 2. So right side I have written the formula. So this is the original formula. So here a for a is equal to 1, b equal to n, isn't it? Okay. Then 1 by 2 pi 0 to 2 pi x into sin n plus 1 x dx minus 0 to 2 pi x into sin n minus 1 dx dx. So there are two terms. Both terms have more than two functions in the integral. So that let us apply the integration by parts for both terms. So it will be u equal to x du equal to dx, dv equal to sin n x n plus 1 x, v equal to minus cos n plus 1 x by n plus 1. Similarly, go to the second term, u equal to x, du equal to dx, dv equal to sin n minus 1 x. Integrate, it will be minus cos n minus 1 x divided by n minus 1. Okay? Okay, now for the next thing. So 1 by pi, 1 by 2 pi. So this is the expansion of the first term as well as the second term. Pink color first term, green color second term. Okay, let us apply the UV formula, isn't it? Okay, now go to the next one, sky blue. The first term represent the sky blue. The simplify, I mean, after integrating the first term. Similarly, the black color after integrating the second term. So the commonly I have put 0 to 2 pi. So wherever we have x, substitute first 2 pi and then minus the lower limit 0, isn't it? Okay, now this is a term. Now simplify an equal to 1 by 2 pi minus 2 pi by n plus 1 plus 2 pi by n minus 1. Okay, now I take 2 pi from the numerator, so 1 by n minus 1 minus 1 by n plus 1. Taking LCM, that is n squared minus 1, the numerator becomes 2. So an equal to 2 by n squared minus 1. So this is the answer for an. Let's move to the third coefficient, that is bn. Bn equal to 1 by pi 0 to 2 pi f of x sin nx dx. 1 by pi 0 to 2 pi f of x will be sin x into sin x sin nx. So there are two signs. Okay, sin A sin B is equal to, so let us check this formula. Sin A into sin B equal to cos A minus B minus cos A plus B by 2. Okay, so using this formula I can split the integrand. So it will be 1 by 2 pi 0 to 2 pi x into cos n minus 1 x dx minus 0 to 2 pi x into cos n plus 1 x dx. Okay, so now I have used the integration by formula. Already we have used in the previous, that is an, previous coefficient, that is an. So the same formula I'm going to use here. So it will be this is, okay, yeah, u equal to x du equal to x, dv equal to cos n minus 1 x, v equal to sin n minus 1 x by n minus 1. U equal to x, dv equal to du equal to dx, dv equal to cos n minus 1 n plus 1 x, v equal to sin n plus 1 x by n plus 1. So bn equal to 1 by 2 pi. So after integrating this, the first term and second term becomes, okay, x into sin n minus 1 x n minus 1, and then x into sin n plus 1 x by n plus 1. Okay, now 1 by pi, substituting the upper limit 2 pi first minus the lower limit second. So I have written the four terms. Okay, so after substituting 2 pi and 0, the term becomes minus of minus 1 by n minus 1 the whole square plus 1 by n plus 1 the whole square plus minus 1 n plus 1 the whole square minus 1 by n plus 1 the whole square. Okay, so simplify this. We will get bn equal to 0. Okay, now for the next one. Okay, so I have an and bn, isn't it? So for an and bn, I would substitute n equal to 1. So the term becomes 1 by pi 0 to 2 pi x into sin x cos x dx. So sin x cos x will be, already we know, sin 2x by 2. So 1 by 2 pi 0 to 2 pi x into sin 2x by into dx. So u equal to x, dv equal to sin 2x. So substituting integration by parts, a1 is equal to 1 by 2 pi minus x cos 2x by 2 plus 1 by 2 0 to 2 pi cos 2x by into dx. Isn't it? Okay, now this is a1 is equal to 1 by pi minus 2 pi cos 4 pi by 2 after substituting the upper limit. What about the lower limit? Both term becomes 0. So that 2 pi cancel. So cos 4 pi will be 1. It will be minus 1 by 2. So a1 equal to minus 1 by 2. Okay, now similarly n equal to 1. Put it bn 1 by pi 0 to 2 pi x into sin squared x into dx. So if you have sine square, it can be replaced by 1 minus cos 2x by 2. So 1 by 2 pi 0 to 2 pi x into 1 minus cos 2x into dx. So separate the term, it will be 0 to 2 pi x into dx minus 0 to 2 pi x into cos 2x. Then after integrating this, 1 by 2 pi x squared by 2 minus x into sin 2x by 2 minus cos 2x by 4, 0 to 2 pi. Okay, then bn is equal to 1, that is pi. So now substitute in equation 1. It means the required Fourier series f of x equal to minus 1 by 2 cos x plus summation. Since already we have found n equal to 1, so that we can start from 2 to infinity. So 2 by n square minus 1 cos nx plus pi sin nx. So this is the answer. Thank you, my dear friends. Thank you, my dear students.